In this example, we're going to run some generative design on a tire carrier. You're going to be given the file. This is in the transportation folder, tire holder. Tire holder 1 is the geometry we're going to use. It's actually a tire carrier. So we have these 4 flanges. Those connect to the vehicle about 9 inches apart. This is the section that would hold your tire and rim on, and obviously that hanging there would create a vertical load. So this is kind of what we're referencing. These flange locations here, you get a gap of about 9 inches, and then this face, we're going to treat that as a solid member where it connects to the tire and rim. We're not going to get too caught up in bolt hole locations, things like that. So okay, we got our 4 flange locations on the vehicle, 1 for our tire. Let's get into it. Alright, in your design drop down menu, you're going to see Generative Design. So click that. We're going to create a new study. So I'm going to lock down some of these parts. We don't want to create new geometry. We're just going to use what we've brought in here. So I'm going to go up to Design Space, Preserve Geometry. I'm just going to lock down these faces. Actually, I'm going to grab these bodies first. We're not. I'm getting ahead of myself here. All right, we're gonna keep that geometry. 5 bodies. Okay. Now, design conditions, structural constraints. All right, here's where we want to lock down some faces. All right, I'm gonna grab these 4 faces. Those are attached to the vehicle. We're going to treat them as rigid members. Let's just call those fixed. All right. Structural load. Let's do this face. Let's mimic a tire hanging there. So, all right. I've got force. I'm going to change my units. I'm going to go pound force, and I've got this set up on a coordinate system, so I'm going to just get my X, Y, and Z here in place. And let's just do 80 pounds force. Okay. Then vertical direction. All right. And go over here to generate. And let that cook for a while. And then we'll be given some options. We'll grab a geometry. We'll export it out of this design study and see what we can actually do with that geometry that comes out. Ultimately, we want to be able to have something we can prep as a step file to be able to print, to be 3D printed. So we're going to export it a couple different ways and see which one gives us the preferred geometry to export to a step file. See what we can do to change the geometry, see what kind of options we have. Once we go through all that, we're going to come back, create a new study, but the second time we're going to create a horizontal load. So we know that tire is going to hang here vertically, but in a given scenario there may be forces acting on it as the vehicle moves to go left and right. So we're going to get our baseline with just the vertical load, come back, apply maybe a 5 or 10 pound force horizontally, and compare those results and see what we're looking at from there. So, all right, we'll let this cook and we'll come back to it. Okay, what we just did was the previewer. If that looks like things are headed in the right direction, we still need to generate. All right, so we'll quit the previewer and go ahead and generate our study. All right, now we'll let that cook for a little bit. Then we'll be given some options and we'll take a look. Now we're starting to get some previews. Grab one of the geometries that looks halfway reasonable. Discard these these goofy looking ones on the left. Grab some geometry, and then we will go up to Design from Outcome, Mesh Design from Outcome. Try using both of these. See what happens. See which one gets you to a step file. See which one you can manipulate and edit. See, just compare what these two outcomes do for you. And then we'll go from there. See which one we can get to a step file for the 3D printer. See which one we can, stretch and change and kind of manipulate easier than the other. And we will go back, run a new study, put a horizontal load, and compare that with what we got here. So, good luck, share your results, Godspeed.